Hey, welcome back everybody. Jeff Frick here, coming to you from the Humanoids Summit. It's the very first one in the Computer History Museum in Mountain View, California. We're excited to get here, talk to some of the people that are really on the cutting edge of what is an amazing transformation and really something benefiting from all these exponential technology curves. And I think they're a little bit closer than we think. So our next guest here, he's Rob Knight, the founder of the Robot Studio. Rob, great to see you.
Pleasure to be here, thanks very much.
Yeah, so you had a great keynote earlier today, and in terms of talking about when is this going to happen, you queried the crowd. I wasn't sure which way you were going to start. You started with, is it going to happen in 25 years? I think the question was when we have these things in our home, and then you started counting down, 20, 10, all the way down to 5, and some people think even sooner than that. So you've been in the industry for a little bit. Talk about kind of where we are in terms of how the industry's moved, taking advantage of things like exponential curves, taking advantage of things like LLMs and new ways to train and learn, and you even do the hardest part of the whole thing. You're a hand guy, which even most artists don't even go after hands. It's like the last thing they want to learn. So where are we kind of in the state of this humanoid robotics thing?
That is $1 million question. I think we're right on the brink. I would say we went past the point of technical capability definitively last March. It's one of the things where you can look back and say, oh yeah, from that point onwards, there were no fundamental unknowns anymore. For a long time, there's always been something we didn't know how to do. There was always something.
The last one to fall.
I would say it was when the LLMs were shown that they could generate chains of motor commands to solve complex tasks automatically. And the company that demonstrated it was Agility. They published a video in March of 2023 where they gave it a 4-word command. And you can look it up on YouTube, and they ask it, clean up this mess. And that was it. And from that, they spent 2 weeks writing a prompt. So they solved a problem using an LLM, which for decades, for 60, 70 years. Since AI was formed, that problem was it was so difficult, we just tended to ignore it. We knew it had to be solved at some point, but there was enough other problems to be dealing with. You still had to solve vision and sensors and motors and batteries and all this other stuff. And that was kind of waiting for us at the end. But even once we've done all these things, you're still going to have to explain to the machine what a thing is. What does it mean to clean? What does it mean? What is a mess? And LLMs, by giving a method to tackle language, they accidentally solved that.
Yeah.
And Agility were the first person to publicly demonstrate that you could do that. 2 weeks to write a prompt, you fed it in, the guy walks on screen and he says, clean up this mess. And it fully automatically worked out by itself what it means to clean, what a mess is. It knew what the objects in front of it were. It knew that it could bend down, it could pick them up. And that was it. And it built the entire process fully automatically, and then it executed it.
That's wild. Now, the other piece I think that the LLM story doesn't get enough pub about is the fact that it is now a really high functioning voice interaction with a machine, which we've never really had that good where it feels so conversational.
Yeah, I think you'll get, in terms of like a no-code solution, you'll get to the point where the vast majority of people will never code a robot. They get it to do really sophisticated stuff, and you'll talk to it much more like you're explaining things to a child. You'll educate it, and they get better and better. And then at some point, actually, they might get smarter, which is something we can get into later. Maybe that's a scary prospect. But in the beginning, something I think which is largely unappreciated is there's a lot of nuance into what we're going to want them to do. And if you think about how annoying technology can be when you're trying to work on something and it's not doing what you expect, or something happens, and at the moment you just slam the lid on your computer, like, I'm done, come back in later. These things are going to follow you around, right? And you're going to sit there watching them mess stuff up and trash your house because you gave it the wrong instruction. That's going to get really, really annoying. So they have to be really good. They have to do what you want, how you want, when you want, in the way you want, so you can then leave them to get on with it. And that level of transfer of expectation, of cultural nuance, that data doesn't exist. That's untapped, and we're going to have to do that process. We're going to have to teach them all of that.
Right, but what's interesting too in the way that the new models work is that used to be silly computer would only do exactly what you told it to do, to your point. And if you got the instruction wrong by a decimal place, a period put in the wrong place, a space.
Of a rocket where it crashes, they missed a slash.
Yeah. But these things, but now there's kind of a new learning paradigm where it's not so much bound by that, and that's really kind of, I think, changed the game in terms of how fast and the way that you can actually train these things. How has that impacted the way you train?
I don't think we're actually seeing that in the wild yet. At the moment, you're still using keyboard, you're still doing mouse, you still have to know what you're doing, you're still having to painfully program it. The people I'm working with, because I'm really a hardware guy. I do the hands, I love the hands, I like the mechanics. I take it up to a microprocessor level and I interface to a higher system. And I have, if you want to call it a strategy, I've simply waited for this day to come, where you can fit these much more powerful systems on top and they tackle a whole bunch of problems that I don't really understand or care to. I'm not great at maths, I don't understand the equations, I'm not a great coder, but I'll know how to use the systems. But that's coming, and it's coming really fast, I am assured. You'll be able to add these foundation models, you'll be able to add language, it'll have a database, it knows what it's doing, but we're not actually there yet. So I don't know, I haven't had that. I've had a little bit of it. With the hand, one of the demos we did is we connected it to ChatGPT, and we asked it the first question, just to check it was running, what is 2 plus 2? And it held up that finger, the ring finger, right? And we said, okay, no, you've made a mistake. To which it replied, no, I replied in binary. Now you've got to unpack that, right? So not only was it right, but it had responded in a more efficient system, and it could tackle that question. And there's a similar story with the agility guys, in fact, that when they first asked it to clear up, it put the bubble wrap in the normal bin, not recycling. And they said, we thought we'd made a mistake. And when they checked, you can't recycle bubble wrap in that state. So that system had gone out and checked and was already doing things better than they would have done it. And at that point, they were just like, okay, that's actually really not sure what we've done now. That's kind of, that's a bit too much.
Pick your words carefully here.
Yeah, so they're gonna surprise us.
Yeah.
I think one of the things they'll have to get really good is apologizing when they break stuff. They're going to like, oh, sorry, I broke your thing. And there's going to be weird, it's going to be a lot of weird stuff, I think. It's not, whatever it is, it's not going to be what you expect.
Yeah. Well, one of the concepts that you're a big fan of that continues from prior generations of computing, not just robotics, is open source. And really this whole concept of publishing everything, leveraging the creativity and the thought and the hard work of a community to move things around, a passion. So I wonder if you can share a little bit about, where does that ethos come from, and how's that enabled you to kind of move the ball down the field a little bit faster than you would have by yourself? Like you said, you're not necessarily the fastest guy on the math chart, but how has open source really changed the game?
Open source has changed a lot of things. And if you go back to the beginning, it was called a cancer, I think, by Steve Ballmer. They really hated it. But the world is not the same as it was then. All of these components, and there's a lot of exponentials, the cost of batteries, the cost of sensors, the cost of computational power, all of these things have contributed to making it possible. And in the sense that open source software could not exist if there weren't lots of devices for people to program on, it was necessary to get to where we are now. But now where we are, open source LLMs are routinely faster and being developed faster. And it allows people to just put their curiosity and their passion into it without being constrained by the concerns of shareholders or concerns of their boss or concerns of whatever else, but commercial systems have to exist within that constraint. So you can attract really good people, you can get them to engage for free, and essentially that's how I leverage my capabilities. But I publish what I do because I believe in the democratization of it, and I have for a long time. The question, in fact, was about where did that start? And my very first professor, who got me started on this whole track, he was keen on that from the beginning. Although we never really talked about it much, and maybe I'll hit him up and say, actually, exactly why were you so keen on democratization? Now it makes a lot of sense. This was 20 years ago, but he was always keen on it. I think, for me, this is a technology which has the potential elevate everyone, to free everyone from the dull and the dirty and the dangerous and the unpleasant repetitive jobs. And that's why I gave these quotes in the talk, that as early as Aristotle, it was appreciated in this world there are masters and there are slaves, because there are just unpleasant things that have to be done. But when you have physical intelligence, when you have machines that literally don't care, they literally don't care. If you make them clean the most disgusting thing in the world, they don't.
Have you seen Westworld?
That gets nasty, right? Okay, no into sex bots already. But
sometimes they don't like that. But it's true, right? I mean, it's.
Oh, no, but it's a really serious question. If they say they don't like it, will you believe them? Can a robot have job satisfaction? Is that, and you cut to a very deep question about sensation of existence, about phenomenology, the sense of self. If with humans, I think, therefore I am. But the machines, I say I think, therefore I am. It's not the same thing. And if you can, I think particularly actually there's a real clear division that if the processing system of the computer is a finite state machine, you can make an exact copy of it and you can replicate it somewhere else. You can't say it's alive because it can be totally known. Now, if you get into quantum, and I don't know if I asked Susan Gilder to come, I'm not sure she is. She's setting up a company called Robotic, and she's very clear on this. If you put your processing in a quantum machine, in a quantum computer, you don't have that same decomposition to base material. In a finite state machine, you can know exactly what everything going on in that machine is. You can know it utterly. But we can't do that we don't think we can do that with a conscious machine. I don't think you can do that. I think there's something deeper. And that's what gives this sense of self. That's what makes it, that's what gives meaning. That's what gives that sense of existence.
Yeah.
If the machines don't have that, they can make you feel sad. They can make you feel happy. They can look like they care. But do they really?
Well,
it's a really important question.
The other great line, right? If you can't tell the difference, doesn't matter. And then the other piece that just fascinates me about the AI and these models in general is that they're so big and complex, and the data is getting updated and refreshed all the time, and the model is evolving all the time. That's why I think, explainable AI and, can you deconstruct the exact reason why it gave you that answer just now, and it can't.
Yeah.
Well, let's shift gears a little bit and talk about safety, right? And I coming into this thing, I didn't have safety right at the top of my mind, but it's on the top of pretty much every talk, and it makes you think back, okay, well, I guess if you go into a factory and they have machines, they have big giant yellow tape all around the areas, so these things can be dangerous, where what we're trying to do here is put them in people's homes with, elderly care is one of the biggest applications. So how do you think about safety? How does the industry think about safety moving from industrial, very controlled environments, you can rope it off, versus leaving it at grandma's house and trusting that it's going to take care of her, it's going to take care of the dog, and I don't really have to worry about, or even as you said, giving it the bad prompt, and it, rather than cleans the windows, smash the windows. I mean, you open up all kinds of potential funny things happening here.
Really, really do. Maybe that's the new frontier, in the way that we used to ignore this problem of how you get it to understand things. We really don't know. It's a very serious problem, and there's a bunch of stuff there. So first off, the technical comparison between industrial robots and what we're trying to produce here. Industrial robots are fixed-based generally. They're made of metal, and because of the control architectures which existed when they were first developed, they need to be as stiff as possible. And this is fundamental to how they operate. You only know motor position.
Stiff because you want it to be in a place in space, exactly.
Exactly, and
to the tolerance.
So we have like a tolerance of 100th of a millimeter, so 1/10 of the thickness of a human hair. Really incredible. And when you see a precision robot operate, it's very impressive. And actually, if you get the chance, and normally you're not allowed to, but if you go and try and move one, it might as well be made of a solid piece of metal. That's how stiff they are. I have a story about that. In fact, one of the universities I used to work with, they couldn't find a robot that was compliant and did all this other stuff. So they bought themselves 2 industrial arms, and they bolted it to a big piece of steel, because they're heavy, and they used to use it to try and assemble toys. And occasionally there would be a student on the other side of the table that was helping it. And then one day they went in, And when they switched it on, it just did a 90-degree with one arm, full speed to the side. And if anyone had been standing there, it would have just killed them instantly. And they never turned it on again. Right, that's an industrial robot. And you can unfortunately find videos of people being killed or being injured, and they don't care. They don't know they're dumb. And industrial robots really are dumb. 50% of industrial robots have no sensors of any type, no cameras, not even touch sensors.
It's running the script.
Running a script. And all of the responsibilities put on production engineer. Now, what we're trying to do is come into dynamic, unconstrained environments. It's novel. That's the kind of words which are used. And specific technical thing that you can do is you can add elasticity to the structure. And that means you no longer have a tight relationship between your motor and your output. This is true of humans. If you consider any athletic action, throwing a baseball, hitting a tennis ball, you wind up, you store energy, and you release it. We get dynamic performance by storing mechanical energy, and it doesn't limit accuracy. It's part of that process. So the question is, can you use AI, intelligence, visual feedback, to compensate for having an elastic body to still produce accurate output? And the answer to that is yes, you can, with LLMs, with other techniques.
Right.
So that solves one aspect of it, but it doesn't eliminate all the risk. And if you consider how heavy a person is, if you want to pick someone up out of bed, you need a lot of force to do that. It has to be strong, which means it likely has to be quite heavy as well. And that brings you back into this problem that if you make a machine which is strong enough to be useful, it doesn't matter if it's compliant, it has the capacity to do a lot of damage. And there's no fundamental way that I know of to prevent that. Same with the really obvious ones. If you want it to use power tools and it can pull a trigger, it can shoot a gun. So you can teach it all about guns so that it knows to avoid them, but if someone hacks that, you've given it all that knowledge, and then you just flick a switch from don't to do, and then you've armed it. So like Asimov's laws don't play out in the real world.
Right.
If it can be programmed, it can be hacked. If it can be hacked, it can be broken into, and it can be made to do something it wasn't meant to do, or it could just do a flat-out accident. So the safety, ultimately, I suspect it comes down to convenience, in the sense that if you look at the privacy issues that surround mobile phones and online data, it doesn't stop people using their iPhones and their smartphones because it's just so convenient. You just kind of ignore the fact that, yeah, maybe they're listening, but in the end, I'm not going to do it. And the same with driving. It's ridiculous. You think about how many people die on the roads. We're not going to stop because it's just so convenient.
Right, right.
So if they get good enough, if they're convenient enough, people will subconsciously basically ignore the fact that once in a while, it might be something you don't want.
Or the insurance companies can justify the trade-off,
and
right?
maybe that
ultimately that'll be
It'll
it.
come down to a really, like an insurance settlement. And you hear stories, and you just think, yeah, but it'll never happen to me. And life will go on.
Yeah. Let's shift gears, talk about hands.
Thank you.
How did you pick hands? I mean, hands are, like I said, even great artists, that's the last thing they learn how to draw in a static position.
Okay.
Yeah, you usually look closely. They're hidden under the clothing.
It's true, but
Clothing is also hard, to get great.
Hands are extra in a portrait, this I know.
Yeah, and I think I saw, getting ready for this, you talked about one of the reasons that your hand has 4 fingers and a thumb is actually for learning and teaching and trying to model human behavior. I don't know if I'm getting that right, but give us a little bit of your philosophy on hands, your specialty on hands. Why do you find hands so fascinating? What are some of the big challenges that most people weren't able to overcome that you've seen some progress against?
I guess hands are like the tires on a car, right? It's the bit which makes contact with the surface. So if you don't have good hands, you're just going to limit what you're capable of doing. And the whole point of them is that they can do a lot of general tasks well. If they can't do that, then there's no point to them. From a personal perspective, I don't know. I'm not quite sure why, but I always have. I built hands in cardboard when I was a kid. I built them in metal and aluminium when I was at school, and now I 3D print them. I've just always built hands. The best I've got is that it's really difficult, so I'm unlikely to ever get to the end. And I think the worst thing in life, but a terrible thing in life is if you set yourself a goal and you achieve it, What are you going to do afterwards?
Yeah, you got to move the goalpost.
So I wanted something, the whole thing, the whole humanoid, just pick something really, really difficult. It's a good game to play. It's an intellectual challenge, which I don't think I'll ever finish. And that's great. It just gives you something to keep yourself occupied.
And what were a couple of key breakthroughs that really made them hand-like in terms of motion or ability, or what were some of the kind of milestones that you hit where you're like, wow, this is getting closer to the hands that I envisioned?
Understanding more about the deep mechanics of it. If you look at the way that joints are constructed in organic systems, you have this synovial fluid, which is actually a very complicated molecular mesh, which has water molecules, and it achieves a level of friction which can only be replicated with roller bearings. So once I started changing over, actually the new one, I'm not using them. So I went through a phase where everything was ball raced, and everything got lighter, everything got faster. And the video, which is done by far the best, and which is, I've really used it as a lightning rod to draw attention to what I'm doing, and published it. And to my great joy, there's a student that turned up at this event that made one, and he's made it better, and he's added to it. And I've got other people that are making double the size and all this kind of stuff. And that video where it moves, and it does something visceral to people, where you just look at it and go, oh, I've not seen something move like that before. They're just fascinating. There's just something about hands. I got nothing better than that.
Yeah, I love it. And is the vision that you would potentially, the hand would be open source as part of somebody else's robot, so they could focus on something else and then go ahead and plug in your hands?
100%, yeah. I've already open sourced the Dex Hand V1, the Robot Nano hand, and the Hope Junior hand, and they are all slightly different variations on the theme of hands. I'm about to open source for V2. Actually, we tried to commercialize the V2 and we realized it's too difficult. It's not suitable for commercialization, for productionization. So my long-term plan is to open source everything I design, but at the same time, you've got to be realistic about, even the artist has to put bread in their mouth, so there's a delay. And the V2 I was kind of holding on to, and now I've decided, no, it's time to just put that one out there as well, and people can get on with it. And then it becomes more, actually. That's the best thing about open sourcing it. People do things you didn't expect, and they take it in new directions, and they push it on.
Right. So I used to be in the TV business years and years ago, and also from the Jetsons was the flat screen, which everybody wanted, and I was selling CRTs and big screens, and there was no such thing. And I still remember the day I saw the first flat screen in a secret private room at one of our shows that was probably 9 inches, maybe 7 inches.
Okay.
And it was ridiculously expensive and unbelievable to even fathom. And here we are, they're super cheap. You can get a 90-inch flat screen. They're ubiquitous.
Unbelievable.
So in thinking of that, when do you think we're going to get Rosie the Robot? Or some quick approximation? Do you think it's, to answer your own question, is it 25 years? I don't think so.
I don't think
Is it 5? Is it 10? What do you think?
There's a scaling issue, essentially, but in the way that I mentioned, you can't have this ChatGPT moment because you don't have billions of devices out there. When ChatGPT was released, it just appeared on every computer, every computer with a browser, every phone. It's just there. That can't happen. And we were discussing this, in fact, this morning. But maybe the point for robots is when they can build themselves, which I know Tez is already trying to do, and it's something we're looking at. When you have a design which can build itself, then you can get, that's a double exponential, right? So then things go very, very rapidly at that point. I think, from what I can gather, the software will be there. The software's there, actually. The kind of demos you're seeing now, you've got companies commercializing. There's Watney folding towels in hotels. There's physical intelligence opening washing machines. And now they're taking 13 minutes to do a load of washing. You give it a few months, it'll be 6 minutes. It'll be, and once it's fast enough that it's good enough, then you just forget about it. It'll become, in the way that you only notice the internet now when it stops working.
Right.
And you shouldn't. You should just be amazed every time you click something and megabits of data are suddenly in front of you, and you just, anything I want to know. You're carrying around in your pocket more power than sent the Apollo space missions, even on the SIM card, and you were giving me stats about the phone itself. And it's inconceivable how much more powerful that is, and it's ubiquitous,
right,
and it's cheap. But there is this, just a physical issue. The dependency principle comes into play. It doesn't matter how swanky your software is, if you haven't got a physical system to run it on, you don't have a robot. And robots are defined by the fact that they can do physical action. So it's a manufacturing issue primarily from this point onwards, I feel. And that either requires lots and lots of investment, which is happening. There's billions going into it now, factories are ramping up, and in some countries like China, it's by government mandate. They have been instructed, there's a 5-year plan. By 2030, you will be the largest robot producing nation in the world. And the government is stimulating it, and that's going to happen.
Right, right.
Whether or not the rest of the world is willing and capable to catch up with that is
We like to buy Chinese products, so probably it won't be that much further.
It's a serious question,
behind, right?
Because of this trust issue. It's an intimate technology. You're going to leave it with granny. If you have a choice, an American robot or a Chinese robot is going to look after your aging parents.
Right, loves DJI drones. I mean,
it's a serious question, but so you wouldn't,
Yeah.
that's okay for you.
Yeah.
A lot of people have said they don't think they would, and that's going to be a defining feature. And there may be tariffs coming, but I don't really want to get into that conversation.
well, what about, is there some half steps available? I mean, I'd love talking to Andra about the difference between an appliance and a robot. Right, and you know, I think in the investor deck, they talked about, you know, Roomba is like the most successful. I don't know, is it a robot, is it an appliance?
What did they say?
They said,
I know what it is, but is it to them a robot or an appliance?
I think he didn't say. It was in this presentation at the robot show, but I think most people think of it as an appliance because it's kind of a single-use, purpose use. And I know
you have to service it. When it's full, you empty it. My definition is that from the point of view of the consumer, it does everything that you need it to do. It's self-cleaning, it's self-running. Then it's an automatic system which at its zenith is a robot, it's a humanoid robot, I guess. Maybe not even, maybe there'll be like 8-armed robots doing more.
Right.
In our present frame.
Well, I just think as everyone goes back to folding clothes, everybody always talks about laundry, and everyone wants their laundry and their dishes done. So is there,
the daily grind.
Will there be a purpose-built laundry robot? Will there be a purpose-built dishes robot before there's a general purpose, or is it that it's so close that this doesn't make any sense?
I have a feeling the latter, because they've tried it. There was a company called Foldymate, which raised a lot of money and then went bankrupt before it ever shipped product. Might have been a scam, to be honest. And there was the Zoom pizza company that raised like $700 million to deliver really bad pizzas. So it's a general argument which I'm a believer in it, and there is an aspect of faith to it. But the general argument is that the machine can do so many things that it justifies its capital cost. And the problem, of course, is at the moment they can basically do almost nothing. So how do you get from where we are to where they are there? And in terms of the half measures, that's why I do the open source. Because if you're selling a consumer product, it has to hit that standard, and it has to be warranted, it has to be insured, and it has to be certified. If you're giving away free plans to enthusiastic hobbyists who take care of it and nurture it and look after it when it's gone wrong and fix it and make it do interesting stuff, then it can do all sorts of interesting things. Like, if you've got 2 machines, it empties one and puts it in the other, and you can watch it on a camera whilst you're at work, and it does it for you, and you're like, hey, that's great. That's not a product, but it is a half measure. And that's why I really like the open source approach, because you can just push stuff out, essentially unfinished, but good enough. It's got a lot of possibility. And people that are better at me at a whole bunch of stuff,
right.
They get on and they do stuff with it, and then all of a sudden, they feed it back into the community, and most of them will, because they get kudos, they get respect, they get appreciation. And suddenly you've got these systems which are doing all sorts of stuff, and the very best of them, you package it up and you commoditize them, and you make an enterprise layer, and then you've got a business. But the path to get there is much more incremental than saying, we're going to sell this product.
Right.
And that's, for me, the difference.
Right. And the probability of finding the killer app is much greater if you've got a lot of people going down a lot of alleys, right?
It's just playing the numbers, right?
Yeah.
So these companies are going to put $1 billion into a robot and nobody buys any because it doesn't really do what we want. That's a tough sell.
Yeah.
But they've raised the money. They're obviously good at raising the money, and they've done it. And good for them. And I don't mean any disrespect, and I wish them all the best. I just want there to be lots of robots. Genuinely, I just want there to be lots and lots of robots making the world a better place for people. That's the ambition.
Right. Safe robots, simple robots.
I'm not sure they can
Gotta
be
be
simple.
safe, not simple, safe.
They've got to be safe.
It's just funny, you know, it's like, what is time? And, you know, we were talking about the Waymo cars before we got on, and, you know, people have been talking about autonomous vehicles forever.
Sure.
They're here. And so, and then, you know, I've asked people,
everywhere.
Is 5 years a long time? Is 10 years a long time? I mean, what is really a long time? And once you get there, you know, however long it took doesn't really make that big a difference anymore, right?
I guess it depends how far down we've gone in all the various crises which they have to fix. If it doesn't happen in, there's a line, I didn't put it in the thing because I don't have to swear, but in Armageddon, when they land on the asteroid and they break one of the drills, and Bruce Willis says, I guarantee it's not more than 20 feet thick. And they say, how can you possibly know that? He says, because if it is, we're fucked. Right? So if it doesn't happen by 2050, we got a lot of problems. So in that regard, it has to happen by then. And if necessity is the mother of invention, we'll find a way, or we'll accept something slightly less, which solves a big chunk of the problem. The definition will shift over time, and we get to where we get to. I think you'll have you have very impressive working systems now. And the space of time in which it's happening, and you go back, same with LLMs, you go back a year and say what's going to happen in a year? No way. You make photorealistic films from a two-word prompt in a year. Never happen.
Right.
And multiple. There's Sora, there's Honwan, there's free ones, there's paid ones. There's a million LLMs. There's like a million now, right? Doing various things. It was bananas to think that would happen.
Right.
And my feeling is that the same thing will happen with robots. And because it's exponential, you talk about exponential a lot, the human brain is linear. And a while back, I came to this understanding, I know things to be true that I cannot believe. And that's a position I end up in. If you look at the maths, the data, the reality, it's going to happen in a time frame which you cannot believe.
Yeah. Well, in the curve that isn't exponential is the demographic curves, and that's one of the forcing functions, because
very much
we're losing population. We need labor. We need it. I was in this very big conference center doing a food show. There's no people in the whole food supply chain, from planning it to serving it at the restaurant. There's labor shortages completely up and down that entire chain. So
part of the great design, and people don't want to do it anymore as well.
Yeah, there just aren't enough of them. There aren't enough of them.
Yeah, and it's maybe not, a lot of it's not dignifying work as well. So if you can get rid of that, then that's a good thing. So yeah, that's the last ingredient. Technologically, it's been possible for a little while. The intent's been there for a very long time. But the need, the requirement, that to me is the crowning, not glory, the crowning reason, which will force it over the edge. It's possible, but we don't really like it. Like the driverless cars. If driverless cars were mandated by law tomorrow, you'd save 40,000 lives a year from the US alone. And you could do that. You would instantly. You go from 40,000 to 40 deaths per year, overnight. We haven't done it because we can tolerate the inconvenience. If people are starving and the answer is to just mechanize everything, we'd do it.
Yeah.
And we'd do it without hesitation, and it'll happen. And the money will be there, and it'll just happen. So I think, yeah, those forces coming together, it'll just, because it has to. It'll happen because it has to.
Yeah. Well, Rob, I love the enthusiasm, love the hard work, love that you're working on hands. Thanks for stopping by, and best to you, and good luck with the, we'll even shake the hands. There we go.
I should have brought Robot one.
All right. He's Rob, I'm Jeff. We're at Humanoids Summit in Mountain View. Thanks for watching. We'll see you next time.